Section 10.6 is radical equations. So generally, to eliminate square roots when you're solving for a variable, you'll end up, for example, squaring. Now the issue with that is, if you have two sides and you square them, 2 and negative 2 are not equal. But if you square both sides, then all of a sudden you have 4 equals 4. As a result, it looks like they're equal. So what you need to do when you do these is always plug in your answer to the original problem to make sure they work. Your general steps for solving is to isolate the radical, get it by itself, square both sides, which may mean you have to use FOIL or the distributive property, and then if there's any radicals remaining, you repeat the process. Now, when would something like that remain? Usually if you have two different radicals at the beginning, you have to repeat step 1, 2, 3 at least twice. Should only be twice. Then you solve the equation and you check your answers. So the square root of 9x minus 1 equals 2x. Get my radical by itself. The square root of 9x equals 2x plus 1. Again, to cancel this out, I need to square both sides. So I need the square root of 9x squared equals 2x plus 1 squared. On the left side, I'll only end up with 9x. On the right side, I need to do 2x plus 1 times 2x plus 1. You have to resist the urge to square both terms because you're excited and going too fast. Well, maybe excited is not the right term, but sometimes you go too fast. So 2x times 2x is 4x squared. 2x times 1 plus 2x. 2x times 1, another plus 2x, and 1 times 1 plus 1. So we have 9x equals 4x squared plus 4x plus 1. This is quadratic, so I need to set it equal to 0 by subtracting 9x. So 0 equals 4x squared minus 5x plus 1. To solve this, we have to factor. So we're looking for factors of 4 that 4 that adds to negative 5, so it's negative 4 and negative 1. This ends up factoring into 4x minus 1 and x minus 1. So the 4 is represented here. So that means either my answer is x is 1/4 or x is 1. Again, once you have those answers, you need to plug them back in. 1/4 is a little harder to plug in, but 9 times 1/4 would be the square root of 9/4 minus 1 equals 2 times 1/4. Square root of 9/4 is 3/2. 3/2 minus 1, is it equal to 1/2? Yes, so this one's fine. Let's plug in 1. Is the square root of 9 minus 1 equal to 2 times 1? Well, is 3 minus 1 equal to 2? Yes. So again, this one did work out, which means they're both answers. It is possible for them to both work out. It just so happens because this is quadratic, that could be the case, but there are times where it doesn't. Now, if you have two different square roots, and you're like, I can't isolate both of them, just isolate one of them. So once one of them is isolated, you can go ahead and square. Just remember, again, you're going to have to FOIL. When I square the left side, this is 21 plus x. On the right side, I've got 3 plus the square root of x times 3 plus the square root of x. So we get 21 plus x equals, distribute 9 plus 3 square roots of x plus 3 square roots of x plus x. So in total, I've got x plus 21 equals, I'm going to bring the x to the front, x plus 9. When I take 3 square roots of x plus another 3 square roots of x, that's 6 square roots of x. So I still have a radical, right? But I started with 2, and now I only have 1, so that's at least an improvement. I still need to do that same strategy, though, of getting this radical by itself. So I subtract x. So 21 equals 9 plus 6 square roots of x. Subtract 9. 12 equals 6 square roots of x. Divide by 6. 2 equals the square root of x. Now that the square root's by itself, I can square both sides to get 4 equals x. Just to make sure, I would like to plug this back in. When I take the 21 plus 4 from above, that's the square root of 25. Is it equal to 3 plus the square root of 4? Well, that's 5 equals 3 plus 2, which is true. 5 is equal to 3 plus 2, which means my answer is good. Now, what kind of answer will you get if you have a bad answer? You'll end up with something like 5 equals 3 plus negative 2, or something like that, or negative 5. If you had negative 5 equals 3 plus 2, that would be one thing that can happen. Because, of course, if you square negative 5 and you square positive 5, you both end up at 25. But really, this is all that 10.6 is. And we'll move to 10.7, the last section, in the next video.